Have you ever looked up at the night sky and wondered about the possibilities out there? What if our solar system had two suns? What if Jupiter, the largest planet in our solar system, suddenly became a star? It's a question that sparks the imagination and leads us down a path of cosmic exploration. Join me, fellow space enthusiasts, as we dive into this tantalizing thought experiment. Jupiter, a massive ball of gas, reigns supreme in our solar system. This colossal planet, the fifth from the Sun, is a behemoth of swirling gases and turbulent storms. Its sheer size and mass make it a dominant force, influencing the orbits of other celestial bodies around it. Jupiter's presence is so significant that it acts as a shield, protecting the inner planets from potential comet and asteroid impacts. It's a giant, dwarfing all other planets combined. In fact, Jupiter is so massive that it could fit all the other planets inside it and still have room to spare. Its diameter is about 11 times that of Earth, and its mass is more than 300 times greater. This immense size gives Jupiter a powerful gravitational pull which has a profound effect on the solar system. Its swirling clouds of hydrogen and helium are a tapestry of colors. These clouds form intricate patterns and bands, creating a mesmerizing display. The Great Red Spot, a gigantic storm larger than Earth, has been raging for centuries. Jupiter's atmosphere is a dynamic and ever-changing environment, with winds reaching speeds of up to 400 miles per hour. But for all its might, Jupiter is not a star. Despite its size and composition, it lacks the necessary conditions to ignite nuclear fusion. Stars, like our Sun, generate energy through the fusion of hydrogen atoms into helium, a process that releases immense amounts of light and heat. It lacks the one crucial ingredient, the ability to sustain nuclear fusion, the process that makes stars shine. Without this process, Jupiter remains a cold, albeit massive, gas giant. Its core, while hot, does not reach the temperatures required for fusion. This is why Jupiter, despite its grandeur, does not emit light like a star. So what would it take for Jupiter to transform from a planet into a brilliant star? The answer lies in mass. Jupiter would need to be at least 80 times more massive to initiate the nuclear fusion process. This additional mass would increase the pressure and temperature at its core, potentially igniting fusion and turning Jupiter into a star. However, such a transformation is highly unlikely in our solar system's current state. For now, Jupiter remains the majestic giant, a sentinel of the outer solar system. Stars are not just bigger versions of planets, they are fundamentally different. Stars are massive, hot balls of plasma held together by gravity. Their immense pressure and temperature ignite nuclear fusion in their cores. This fusion process, converting hydrogen into helium, releases unimaginable amounts of energy. Jupiter, while massive, falls short of this critical threshold. It's simply not big enough or hot enough to ignite the stellar fire. Imagine for a moment that we could magically add mass to Jupiter. We would need to increase its mass by a lot, at least 75 times its current size. With this added mass, Jupiter's core would begin to collapse under its own gravity. The temperature and pressure would skyrocket, eventually reaching the critical point to initiate nuclear fusion. Hydrogen atoms would fuse into helium, unleashing a torrent of energy, and Jupiter would ignite into a star. Section 5. A new solar system. 2 stars, new orbits, and shifting destinies. Imagine a universe where Jupiter, the gas giant we know so well, ignites into a star. This transformation would not just be a spectacle of cosmic proportions, but would fundamentally alter the very fabric of our solar system. With Jupiter transformed into a star, our solar system would be forever changed. The once familiar night sky would now feature 2 brilliant suns, casting dual shadows and creating a surreal twilight. The dynamics of our celestial neighborhood would be rewritten. We would become a binary star system, with 2 stars at the center. This new binary system would mean that the gravitational forces at play would be vastly different from what we experience today. The intricate dance between these 2 stars would dominate the cosmic ballet of our solar system. The gravitational balance would shift, causing the orbits of planets to rearrange. Planets that once had stable, predictable paths around the Sun would now find themselves in a chaotic scramble to find new orbits. The delicate equilibrium that has existed for billions of years would be disrupted. Some planets might be flung out of the solar system entirely, lost to the vastness of space. These rogue planets would drift through the interstellar void, forever exiled from the warmth and light of their parent stars. The fate of these wandering worlds would be uncertain as they journey through the cold, dark expanse of the galaxy. Others might find themselves in new, elliptical orbits, swinging precariously close to the stars. These planets would experience extreme variations in temperature and radiation, as they oscillate between the scorching heat of their closest approach and the freezing cold of their farthest distance. Life, as we know it, would struggle to survive in such harsh and unpredictable conditions. Moons orbiting these planets would also face dramatic changes. Some might be captured by the gravitational pull of the new star, while others could be ejected into space. The intricate relationships between planets and their moons would be forever altered, leading to a cascade of changes throughout the solar system. Even the asteroid belts and comets would not be spared. Their trajectories would be altered, potentially sending them hurtling towards the inner solar system, or flinging them out into the depths of space. The increased activity could lead to more frequent collisions with planets, creating a more hazardous environment. Earth, with its new dual suns, would experience profound changes in its climate and seasons. The interplay of light and heat from two stars would create complex weather patterns, potentially making some regions uninhabitable while others might flourish. The very essence of life on our planet would be challenged to adapt to this new reality. In this transformed solar system, the destinies of all celestial bodies would be irrevocably altered. The once familiar night sky would be a testament to the ever-changing nature of the universe, reminding us of the delicate balance that sustains life and the endless possibilities that lie beyond our current understanding. Section 6. Earth's Fate, From Blue Skies to Potential Inferno. The fate of Earth in this cosmic reshuffling is uncertain. We might find ourselves in a stable orbit, albeit a different one. However, there's also the possibility of being pulled towards Jupiter or the Sun. If we drifted too close to either star, our planet would be scorched, turning into a barren wasteland. The delicate balance of life as we know it would be irrevocably disrupted. Section 7. Cosmic Ballet, a celestial dance of gravity and light. Despite the potential for chaos, the transformation of our solar system would be a sight to behold. Two stars would illuminate our skies, casting intricate shadows and painting the night with vibrant colors. The celestial dance of gravity between the Sun, Jupiter, and the remaining planets would be a mesmerizing display of cosmic forces at play. Section 8. Life, Reimagined Possibilities on New Worlds. While the emergence of a second star might spell doom for Earth, it could also pave the way for life to arise elsewhere in the solar system. Moons orbiting around Jupiter or other planets might experience a surge in temperature. This warmth could melt ice, creating liquid water, the essential ingredient for life as we know it. Perhaps on these newly warmed worlds, life could find a new foothold. Section 9. A Universe of Wonder, Endless Possibilities. The idea of Jupiter igniting into a star is a reminder of the vast possibilities that exist in our universe. Imagine the transformation of our night sky, the new dynamics in our solar system, and the profound impact on our understanding of celestial mechanics. This concept, while speculative, opens our minds to the endless potential and mysteries that the cosmos holds. While the scenario we explored is purely hypothetical, it highlights the power and beauty of astrophysics. Astrophysics allows us to simulate and understand phenomena that are beyond our immediate reach. Through complex models and simulations, scientists can predict the behavior of stars, galaxies, and even entire universes. This field of study not only deepens our knowledge but also fuels our imagination, inspiring us to think beyond the confines of our planet. It compels us to look up at the cosmos with awe and wonder, asking endless questions and seeking answers in the grand tapestry of stars, planets, and galaxies that surround us. Each star we see is a beacon of history, a story of creation, evolution, and sometimes destruction. The vastness of space reminds us of our small place in the universe, yet it also encourages us to dream big and explore the unknown. The universe is full of secrets waiting to be uncovered. From the smallest particles to the largest galaxies, every discovery adds a piece to the puzzle of our existence. Keep looking up. The night sky is not just a view, it's a gateway to endless possibilities, a source of inspiration, and a reminder that there is so much more to learn and explore. Whether you're an amateur stargazer or a professional astronomer, the journey of discovery never ends.